All right, so now it's time for a little bit more practice. Okay, we want to practice these things so we can get used to doing them. So we're starting out with the first problem. What is the H concentration of a solution with a pH of 3.2? It's got a little pH. What does that mean?
Low pH, that means it should be an acid, right?
That's right. Yeah, you're right.
All
This is
right.
an acid.
So low pHs mean acids.
Because it's less than 7, right? If any pH is less than 7 is an acid. And then, do you remember what the brackets mean?
Brackets, I think you were saying that the brackets mean it's holding a concentration.
That's right. This is the concentration of hydrogen.
All right.
Very good. Concentration.
And concentration is the same as molarity.
Yeah, of H plus. Okay, so now we just got to remember how to find the concentration. So if you're looking for concentration, H plus, that is equal to 10 to the, that's like the second log, right? Negative pH. So we want to do 10 to the negative 3.2, right? So
how do we put that in our calculator?
It's very simple. You want to remember where the log button is. So it's right there. Now we're going to use that log button with the second button. So we're going to go second log and then negative 3.2. So second log, so that's where we get our 10. Negative, not minus, right? I hit that button down there. That negative button.
Gotcha. The one in between the kind of the brackets there, or the parentheses.
Negative 3.2. And then close parentheses and hit enter. Alrighty, so that is 6.3 times 10 to the power of 1, 2, 3, 4, negative fourth. That's how you go from regular to scientific notation.
What if I didn't know how to get that into scientific notation? Is there a way to do that on the calculator?
There is a way to do that on the calculator. You just go to second degree and then go to side or arrow over there and then hit enter. And it shows it exactly the same thing right there. So I can just erase that. There we go. So that's it in scientific notation, if you don't know how to do that.
Gotcha.
Okay, so let's go ahead and write that in. 6.31, if I round, times 10 to the negative fourth.
Oh, almost missed that little guy right there. We have to
put you got to include that down there. For sure, don't forget about that. That'll change the whole number.
Oh, yeah.
All right, so let's try the next one. What is the pOH of a solution if the hydroxide concentration, that's what that means, this is concentration of hydroxide, of OH, is 4.6 times 10 to the negative 9th. Okay, so if we're going from concentration to pOH, we got to remember that formula. pOH is equal to negative log, and then whatever the concentration is. Okay, this number is going to go right in there.
Oh, so we're going to do the negative log, and then whatever that our OH is, we just kind of plug it in there.
Yes, that's right.
Oh, that's easy enough. Yeah.
So let's do that. Negative, down here at the bottom, not the minus sign, log, and then what our concentration is, which is
4.6 times 10 to the negative 9.
4.6 second E, there you go, negative 9, close parentheses, 8.3 times 10 to the 0. Oh, let's change that back to regular. There we go. 8.34.
All right. So a pH of 8.34, since that's above 7, that would be basic?
It is pOH, right? pOH is different from pH. If pH is greater than 7, then it would be. But we can actually figure out if that's an acid or a base, right?
So we can't use the pOH scale the same way as the pH?
Mm-mm.
Oh, okay.
So let's figure out if it's an acid or base or not. pH is equal to, let's see, 14 minus 8.34, and that would be a pH of about 6, 5.7.
Oh, so it would be the opposite.
So it would be an acid. Yep.
Oh, okay. So I guess
That is an acid right there.
I guess we'll have to be careful. So if we get a POH, we can just subtract it from 14, and that'll give us our pH.
Right, yeah.
Okay.
So maybe we should remember that. POH, like, doesn't tell you if it's an acid or not. pH tells if acid or base. Not POH.
Because otherwise, that'd be pretty easy to get confused.
Yes, definitely. So we'll definitely want to remember that. Let's try a couple of other practice problems, kind of putting all this together. Right? We are given a hydrogen concentration, that's H, of 5.5 times 10 to the negative 4th molarity. Find the following and state whether the solution is acidic or basic. So hydrogen concentration. Well, that's right there in the problem, isn't it?
All right.
So 5.5 times 10 to the negative 4th molarity. Okay, so then what would the hydroxide concentration be?
Well, I noticed before when you showed me the different equations we had, can we do with hydrogen ions and hydroxide ions the same as we do with pH and POH?
Right, like they both have to come together to make something?
Yeah, can we do that with concentration?
Yeah, there is a problem for that. There's a formula for that. That would be, let's see, the hydrogen concentration times the hydroxide concentration is equal to 1 times 10 to the negative 14th. And that came from the other notes page, right? So if you want to look at your other notes page, flip that over. It's right there. Okay, so we're doing this formula right here. Okay, so that's right there. So this times whatever the hydroxide concentration is has to equal 1 times 10 to the negative 14th.
So could we plug in the hydrogen and then divide on both sides to find
that's right.
hydroxide?
So this is going to go in right there. All right, so 5.5 times 10 to the negative 4th times the OH concentration equals 1 times 10 to the negative 14th. Okay, so how we plug that in, we got to be really careful with the scientific notation. 1 second E negative 14th, close parentheses, divided by, open parentheses, 5.5 second E, what is that, negative 4. And there we go.
Whoa, that's a weird looking number.
That is a weird looking number.
1.82 times 10 to the negative 11?
Yeah, that is our OH concentration. 1.82 times 10 to the negative 11th molarity.
So, all you did down here was just you divided by the 5.5 to cancel them out?
Yep, that would look just like this. I divided both sides by 5.5 times 10 to the negative 4th, 5.5 times 10 to the negative 4th. These canceled out, and then that
is what you plugged in.
Yep. 1.82 times 10 to the negative 11th, just like that.
Awesome. All right.
And that's what went up there.
Well, I mean that looks weird, but it's actually really.
It is really simple. It's just one step,
yeah.
right? Yeah. So let's do pH now. pH, we know. Define pH. It is negative log the concentration of hydroxide, right? Or sorry, hydrogen. I'm always getting those confused.
They both start with H.
Yeah, they both. Yeah, they have an H in them, or whatever. All right, so pH is equal to the negative log of our hydrogen concentration right there. 5.5 times 10 to the negative fourth. Okay?
Mhm.
So again, this is not, I mean, it's a lot of numbers, but it's also not complicated, right?
Mhm. Now, are we just gonna plug this into the
Just
calculator?
punch that into the calculator. That's all you got to do.
All right. We just have to have nimble fingers.
Yeah, this is going to be a
Yeah.
lot of typing.
Yeah.
Don't forget your calculator at home.
Yeah, that would be bad.
Log, negative log, right? 5.5 second E negative fourth, close parentheses, and there we go. So let's round, okay? Our pH is equal to 3.26, just like that. Okay,
All right.
so that is our pH.
So it's an acid.
It is an acid, you're right. Spoiler alert, right?
Oh, okay. Sorry.
I mean, we don't know.
We have no idea yet.
No. All right. Now let's do POH. So we can find that out two different ways. One, we could subtract this from 14.
Oh, okay.
Two, we could do POH is equal to the log of the OH concentration, because we have that already too. So we have two different options.
So we could do negative log or just subtract from 14?
Yeah. Which do you want to do?
I think I'd prefer to subtract from 14. It just seems faster.
Yeah, why not, right?
But either one would work.
So they both work the same way. pH plus POH is equal to 14, right? So 3.26 plus POH is equal to 14. So subtract 14, or that 3.26, sorry, for both sides. So POH is equal to 14 minus 3.26, and we get 10.7.
10.7.
So, is it an acid or is it a base?
Well, since it's less than 6, I would say that's got to be an acid.
Yep, I think you are right. So, it is definitely acidic. Acidic because pH is less than 7.
And we always got to remember that we're going with the pH.
Yeah, that's what we're
That's
looking
it.
at right there.
Yeah, the POH, that'll get you. It'll give you the opposite answer.
Yes.
Yeah.
All right, well, I think that's it.
Alrighty, if you have any questions, ask your teacher.